Hello everyone, this is going to be part 3 under special functions. In this lesson we can talk about modulus functions. So we'll refresh on this a little bit. I'm sure that you are already familiar with the modulus of real numbers and a modulus of this simplest function, which is the modulus of x. So we'll start with this first. Let's look at what a modulus of a number is. Say this is a number line. In the number line you have 0 in the middle, then you have positive numbers to the right side of it and negative numbers to the left side of it. A modulus of a number a, say a is a real number, is defined as the distance from 0 to a, or the magnitude from 0 to a. That is the definition of a modulus of a real number, or modulus of a number in general. Sometimes people also call it the absolute value of a real number. So let's say if a is around here, this is the distance to a from 0. So distance, we know it is a positive quantity. So the modulus of a is referred to as the distance from 0 to a, which is always a positive quantity. So what happens when a is negative? When a is negative, the only difference here being the sign. So the negative numbers are located towards the left side from the 0. But still, you can see here that the distance between these two values is the same as the distance between 0 and positive a. So in this case, it doesn't matter whether a is positive or negative, this will always yield a positive quantity. If a is negative, this is also a positive quantity. So how do we get the magnitude? You know that the distance or the magnitude is always a positive quantity. If a is positive, the modulus of a can be replaced by a itself, right? But what happens when a is negative? When a is negative, the modulus of a will be replaced by minus a. So to make any negative value positive, you just have to multiply it by minus 1. We'll look at some examples now. Let's say you have 0 here, 1, 2, 3, 4, and minus 1, minus 2, minus 3, this goes on. Let's take this value, the modulus of 3. What is the modulus of 3? Let's look at 3 first. 3 is a positive number. So the modulus means the distance between these two values. We know it is 3 units apart. Number 3, the positive number 3, is 3 units away from 0. So you can replace it by the positive quantity 3 itself. So what about this? The absolute value or the modulus of negative 3. So negative 3 is located to the left side, but still it is 3 units away from 0. Right? So still it is a positive quantity. So this is how you obtain absolute value or the modulus of a real number. So the modulus will just give you the numerical value of that number. Any real number, it could either be positive or negative, but the numerical values is the same in this example. Right, so can you tell me what is the modulus of 0? Modulus of 0 is always 0, because 0 is 0 distance away from 0 itself. It is just a point. Okay, now we have to move on to modulus of functions. So how we define functions first? Uh, this is how we define functions. I think you know this already. Here you have the domain and this is the codomain. So x is an element that represents the domain, and in this example x is said to be any element from the real number set, which means x can take any positive numbers or negative numbers or zero, anything is possible, rational, irrational, anything. Right, so what happens, how do you solve this? So x is a variable here, and you know that when x is a positive quantity, whether it is 0 or is positive quantity, that means if x is larger than 0, you know that any positive quantities can be replaced by itself, right? Any modulus of a positive quantity can be replaced by the quantity itself, so we just leave it as it is, right? For example, let's say x equals 5, right? X equals 5, 3, 2, 1, 0, anything in between, they can be replaced by that number. So what happens when x is less than 0? When x is less than 0, as I told you earlier, that you have to make it a positive quantity, because when x is less than 0, that means x consists of x represents negative numbers. So in order to make negative numbers positive numbers, you have to multiply it by -1, just replace it by x. So this is how you show this. Now if you are asked to plot this or sketch this in a Cartesian plane, how do you go about doing it? So the basic way is to have some x values, then you take the modulus of that. For example, let's say we'll start with -5, -4, -3, -2, this goes on. If x is -5, you replace it with 5. How do you do that? You just multiply it by -1, so that leaves you with 5. So I'm going to do all these numbers. So this gives you 4, 3, 2, 1, 0, again 1, 2, 3, 4, and the list goes on. So what you do, you just plug these values in the Cartesian plane. So when it is 0, you have 0, 1, you have 1, 2, 3, the list goes on. Then what you do, you just connect these crosses. Then you obtain the sketch of the modulus of x. This is the modulus of x. But there's a smart way to do this. If you don't remember this, you can go back to this method, the basic method that you could draw a function. Right. So what is the other method? First, you have to split the function into two regions. In this example, actually there are only two regions. So what is the first region? When the number inside the modulus is positive, you just replace the modulus with the number itself. So how do you write this? When x is larger than or equal to 0, which means x is positive, you just leave it as it is, right? So this is also equal to 1. When x is less than 0, just multiply it by -1. So what does this mean? As you can see here, the function has been divided into two regions, two separate regions. First region, tells you how the function behaves when x is a positive number or equal to 0. Second region tells you how the function behaves when x is a negative number. So this is a semicolon. Okay, don't mix it. Right. So first of all, you have to locate the line that divides these two regions. So what is the line that divides these two regions? So it is divided when x equals 0. So what is the x equals 0 line? X equals 0 line is the y-axis. I think you already know that. Right. So towards the positive side of the origin, the function behaves as y equals x. Towards the negative side of the origin, the function behaves as minus x. So how do you draw this? You know how to plot y equals x. This is how we plot it. You have 0 here, so towards the positive side, the function behaves as y equals x. Right? So original function is y is equal to the modulus of x, but when you split it into two different regions, this is what you get. So you can see here that usually y equals x continues towards the negative side as well, but in this case y equals x does not continue into the negative sides. So what happens in the negative region of x? Negative region of x, y behaves as y equals minus x. How do you sketch it? This is how we sketch it. Minus x. So you are already familiar with sketching straight line in the cards and pens, so I'm not going to go into details on that. Right. Notice this. In this example, y-axis is called the symmetric line, the line of symmetry. This is the line of symmetry, line of symmetry. So why do we call it the line of symmetry? Because the function is symmetric besides this line. That is why we call it the line of symmetry. You can see here this function takes the form of V shape. It is of V shape. So generally when a function is equal to a modulus function alone, it will take V shape, right? That is how you differentiate modulus functions from other functions. But sometimes when it is not completely equal to a modulus function, the shape might change. Right, we will look into examples during discussion. The other thing you should notice is that this has a minimum. This example has a minimum where the minimum lies. Minimum is at x equals 0, right? When x equals 0, y is equal to 0 according to this example. That means the minimum value or the vertex, let's call this vertex, so it is can be used in a general way. Vertex is at the origin 0, 0, right? This is the vertex of this function. So the vertex will change depending on the function. So you're gonna have to be careful when you sketch a modulus function, because when students starts to sketch it, they just keep this shape in their mind, and they always end up having the vertex on the x-axis. But please keep in mind, depending on the function, the vertex can shift vertically upwards or downwards, right? And also it can shift horizontally left or right. So keep that in mind when you solve problems. Okay, we'll look at another example. So this is how the function y equals modulus of x looks like. Okay, what about this? This is another example, a simple example. So what happens? Y equals modulus of x plus 1. So we're going to have to figure out how the graph behaves in certain regions. How the graph behaves when what is inside this modulus changes its sign, right? So you know that in this example as well, it will split into two regions. The first region is when x plus 1 is the argument or the function inside the modulus, is 0 or is equal to 0 or larger than 0, which means x plus 1 is positive. So when x plus 1 is positive, you just leave it as it is, x plus 1. Simple. So when x plus 1 is less than 0, you know that you have to make it a positive quantity, and how do you do it? You multiply it by minus 1. So you multiply the function inside the modulus by minus 1. We'll do another step so it is much clearer. So we can have to figure out the line of symmetry. In order to do that, you can have to go a step further. So sometimes you can just directly write it, but in this example I'm gonna go through the steps. So this is x plus 1. It is when x is larger than or equal to minus 1. So this minus 1 here goes to the other side, because we have to solve this inequality. It's a simple inequality, and I'm sure you are already familiar with these types of inequalities. Right, when x plus 1 is less than 0, which means when x is less than minus 1, the function behaves as minus x minus 1. Right. So how do you draw this function? First, you have to locate the line of symmetry. So what is the line of symmetry? Line of symmetry means the line which divides two regions. So you can see here that x equal minus 1. X equal minus 1 is the line which divides these two regions, right? Okay, we'll change the in color here. So where is x equal minus 1 line? X equal minus 1 line is the parallel line to the y-axis, which goes to minus 1, right? Okay, so towards the right side, from minus 1, the function behaves as y equals x plus 1. Y equals x plus 1. So how does the function y equal x plus 1 behave? You know, the intercept here being 1, so just have to draw this like this, right? So in this example, like in the previous case, the vertex is at vertex lies on the x-axis, but the x value has been altered. Earlier it was x equals 0 and y equals 0, right? So you can write it like this, be 0 0. But in this case, the vertex, the coordinate of the vertex is at p equals minus 1 0. This is the vertex, right? So what happens in the left side? Left side, it takes the form of minus x minus 1. Here you can see that intercept is minus 1. So minus 1 is somewhere here. Minus 1. Here 1. But the function doesn't continue with this beyond the minus 1. So we're going to make a discontinuous line. You can, it is okay not to do this, but since we are learning this from the basics, make sure you use a discontinuous line up to minus 1, and the line continues like this. So after doing this, you can have to make sure to write the function or the rule which applies. X plus 1, and this branch is y equals minus x minus 1. Right. So this is the next, the second example we looked at. We'll be looking at more examples during the discussion, starting from the basics, and we'll move on to difficult ones. Okay, I'm going to talk about something very important here now. Let's address this. Don't worry about this for a moment. So how do you sketch the modulus of function when the function is given in a Cartesian plane, say y and x? So a general, I'm just going to sketch a general function like this. I'm just going to draw it, right? Any general function. You can see, yeah, I'm just going to call it y equals f of x. You can see here base values here and here. Let me call this a, b, c, d. So between c and d and between a and b, you can see here that the function takes negative values, right? So beyond a towards the negative side, the function takes positive values. Between b and c, again positive values, and d onwards, y takes positive values. So if you are asked to draw y equals modulus of this function, any function, okay, modulus of this function, using this graph given, how do you draw it? You know that if the function takes positive values, you just leave it as it is. But when the function takes negative values, you just have to multiply it by minus 1, right? So between these two regions, between a and b and c and d, you just have to multiply this function by minus 1 between these two. So what happens when you multiply the function between these two regions by minus 1? It will just I will try my best to make it symmetric. It will just flip towards the other side. You know that let's say that it is minus 3. If you take the modulus of minus 3, it will go back to positive 3. It will just flip onto the other side. Right, so you can see here that the function between these two values c and d, what it has done is it has been flipped, right? So you can see here that the red line is quite symmetric to this green line, and the line of symmetry being here the x-axis. Same thing happens between a and b. So this is how you deal with functions when they are plotted in a Cartesian plane, and if you are asked to plot the modulus of that function, this is how you should draw it. You know, but so you have to draw this as well, because positive values can be left as it is. The only difference that you make is you should flip the signs of negative values. That's what you do. So in general, if a function is given, this is how you solve it. In general, let's say you are given the function of f of x. This is a general rule. Be a linear function, a quadratic function, whatever it is, you have to solve it like this. So the function will behave differently in different regions. So what happens when the function takes negative values, which means when f of x, you know, is called an image So well, let's look at this first. When f of x is equal to 0 or larger than 0, you know that you can just leave it as it is, right? If the function is positive, you just leave it as it is, f of x. So by solving these inequalities, you will get the line of symmetry. So what happens when the function takes negative values? If the images are negative values, sorry for this, negative, what you have to do is that you have to multiply the function by 2. So this is how you deal with modulus functions in general. So we'll be looking at different examples in the discussion. If you have any questions, please refer to me them during the discussion. Okay, I'm gonna stop this video here. Thank you for watching.